So let's have an axis for the voltage and an axis for the current, which increases the resistance of a battery. And that is that they contain... I'm Esah from Understanding Physics. In the last video we saw how a battery creates its own electric current. Well, in this video we're going to look at how this same battery has its own internal resistance. Now in the previous video we learnt an electric current is the flow of electrons. Well, it's not just the flow of electrons. We can improve that definition a bit more, so that an electric current is the flow of particles with charge. So an electron has charge, so does a proton, so does a particle called an ion. Now an ion is simply a particle where it's had an electron removed, or an electron added, or maybe more, to change the overall charge of the particle. And if these particles flow within a battery, then there must be an electric current. If we remember from Ohm's law, V is equal to IR, that if you have an electric current which is large, well, that means the resistance must be small. And that's what happens in a battery. Because they allow a large electric current, that means that the resistance of the battery is small. But hang on a second, where does this idea of internal resistance come from? Well, it all comes from the fact that these flowing particles form part of a solution called an electrolyte. Now, an electrolyte is normally very good at conducting electricity. It contains freely moving positive and negative ions, which allow an electric current to transmit through the battery. But there's one aspect of an electrolyte which increases the resistance of a battery, and that is that they contain acid. Now, if you've dealt with acid in school, you'll know that acid is very corrosive. It breaks things down. I wouldn't recommend you deal with acid unless you have a teacher present, which might be one of my parents. But the aspect of acid which really increases the resistance of a battery is that they react with the material within the battery itself. They react with the metal and other things and corrode it. Once it's corroded, it releases material of high resistance. On top of that, once they react, we lose the electrolyte. We lose the substance which transmits electricity through the battery. Both of these factors together increase the resistance of the battery. Now, if we remember, resistors dissipate energy. So if we place a battery in a circuit with a resistor, well, that means that the energy will be lost in the resistor as well as in the battery itself, because the battery has its own resistance. But how much energy is delivered to each part? Well, if we call this resistor capital R and this internal resistor small r, then we can use Ohm's law to say that the energy delivered for each charge is equal to IR plus I small r, or that the total energy delivered to the whole thing, which is called the EMF, E, is equal to I small r plus I capital R. Now we want to deliver the energy to this component here. It might be a resistor, it might be a filament, or it might be the screen of your iPhone 10. That's my actual phone. The important thing is that the resistor here is where we say that there's a terminal potential difference, V. So we can change the equation to E is equal to V plus IR. Now you'll notice something interesting about this equation. If we increase the current, because the potential difference across the whole thing, or the EMF, is the same, this battery doesn't change in capacity, that means that the terminal PD, or voltage, has to decrease. We can plot this relationship on a graph. So let's have an axis for the voltage and an axis for the current. Well, when we increase the current, as so, the voltage will decrease. You'll notice that the starting voltage is the EMF, and the voltage as it decreases is the EMF minus the voltage due to the internal resistance. The equation of a straight line is y equals to mx plus c. Well, if we compare it to our equation of V is equal to E minus IR, then we can say that the gradient must be equal to minus R, or minus the internal resistance. So there you have it. That is how the graph of internal resistance works. Thank you for watching this video. If you've got any suggestions for future videos for me to make, please comment below. If you've got any questions about what I've just discussed, also comment below. And just have a nice day. Just to add to last week's video, the electrons are attracted to a large number of donuts because it represents a region of large negative potential. And negative potential is where the oppositely charged particle will be, and opposite charges attract. You can also think of it as having a lower potential energy, just like how the number -5 is less than 0. And so all objects prefer to go from a higher potential energy to a lower potential energy because you don't have to do any work to get there. But we'll explore the concept of work, fields, and potential in a future video, hopefully. But until then, once again, thanks for watching.